A model of carry-on luggage has a length that is 6 inches greater than its depth. Airline regulations require that the sum of the length, width, and depth cannot exceed 24 inches. These conditions, with the assumption that this sum is 24 inches, can be modeled by the function v of x that gives the luggage's volume in cubic inches in terms of its depth, x, in inches. If its volume is 432 cubic inches, determine two possibilities for its depth. So according to this information, the length, if the depth is x, the length is x plus 6. And let's see how we're going to represent the width, since length plus depth plus width has to equal 24 inches. So that means x plus 6 plus x plus width is 24. So if we solve that for width, we get 24 minus the sum x plus 6. And if when we simplify the parenthesized expression, we get 2x plus 6, which is what we're subtracting from 24. So we get 24 minus 2x minus 6, which is 18 minus 2x. And that's how our width would be represented given the information that the problem gave us. Now we're told that volume is 432 cubic inches. And volume is length times width times depth whenever you have a geometric figure with this three-dimensional shape. So we put 432 in place of volume, x plus 6 in place of length, x in place of width, and 18 minus 2x in place of depth. And so we can switch that around and put the x first, and that whole right side can become our left side. Let's factor out a negative so that we get negative x times 2x minus 18 times x plus 6 equals 432. When we factor a negative out, the subtraction changes, we reverse the terms. And that's what we've done there. All right, when we use the distributive property to multiply that, 2x minus 18 times x plus 6, we get 2x squared plus 12x minus 18x minus 108. And let's distribute the negative x to get negative 2x cubed minus 12x squared plus 18x squared plus 108x equals 432. Let's combine our like terms. We get minus 2x cubed plus 6x squared plus 108x equals 432. Now let's add the opposite of everything on the left side to the 432. And then let's move that to, so this becomes 2x cubed minus 6x squared minus 108x plus 432 equals 0. And we see there's a common factor of 2. Let's factor that out. And 2 is multiplied by x cubed minus 3x squared minus 54x plus 216. So our leading coefficient is a 1. The factors of 1 are plus or minus 1. Our constant is 216. The factors of that are many, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 8, plus or minus 4 plus or minus 24 plus or minus 54 plus or minus 48, and so forth, so on. There's many, I've got quite a few of them. Obviously, the ones that are going to work are probably going to be the ones that are between 3 and 12. The others are too small, the others are too big. So we're going to work on solving x cubed minus 3x squared minus 54x plus 216 equals 0. And we're going to use synthetic division in order to see what I'm going to start with 3 in order to see whether or not 3 is a root. We bring down the 1, multiply by 3, add that to the next coefficient, multiply the sum by 3. We keep repeating that process, and we find out that our remainder is 54. Since this isn't 0, that basically tells me 3 is not a 0 of the polynomial. Let's try negative 3. Maybe that one will work. So I write down the coefficients of the polynomial, bring down the leading coefficient, multiply by negative 3, add that to the next coefficient, I get negative 6, multiply that by negative 3, I get 18, add that to negative 54, and I get negative 36. When I multiply that by negative 3, I'm going to get a positive number. Technically, I could stop because I can see that the remainder is not going to be 0. But let's go ahead and do this product, which gives me a positive 108, and I add that to 216 and get 324. That's not, so my remainder isn't 0, so negative 3 is not a 0 of the polynomial. Let's try 6. Let's write down the coefficients and let's repeat the process. And I see that I do get a remainder of 0, so 6 is a 0 of the polynomial. So what that means is I can write this polynomial x cubed minus 3x squared minus 54x plus 216. I can write that polynomial as x minus 6 times x squared plus 3x minus 36. Notice the coefficients of this second degree polynomial come from the coefficients of my synthetic division. So the 1, the 3, and the negative 36 are the coefficients of this second polynomial. So we're going to take each of these polynomials and set them equal to 0. X minus 6 is 0, which means x is 6, or either x squared plus 3x minus 36 is 0, which means, I'm going to use the quadratic equation or quadratic formula to solve, since this is a quadratic equation. A is 1, B is 3, C is negative 36. So x is negative b, which would be negative 3, plus or minus the square root of b squared minus 4ac. So 3 squared minus 4 times 1 times negative 36 divided by 2 times a, which is 2 times 1. So this is negative 3 plus or minus the square root of 9 plus, I have a double negative there, 144. And all of that is over 2. Well, this equals negative 3 plus or minus the square root of 153 over 2. So x would be a negative 3 minus the square root of 153 over 2. The problem told us to round. This is negative. So negative 3 is already negative, and if I subtract whatever the square root of 153 is from that, then I know I'm going to get an even more negative number that's going to be divided by 2. So a negative number doesn't make sense for the problem, so that's not applicable. So let's calculate when approximate negative 3 plus the square root of 153 over 2. And using my calculator, I get approximately 4.7. So those are my two possibilities. The depth is either, and that's all we were asked to find for the problem was the depth. So the depth could be 6 inches or about 4.7 inches.